Okay, so let's look at that integral there. We have to find the reduction formula. Okay, so how do we go about this one? So just similarly to the one for tan that involves tan to the power n of x dx, we can try to write this in the form sec n minus 2 of x, then we'll have sec squared of x dx. Okay, and remember to say when I was dealing with tan, okay, when we are dealing with tan there, we said the integral of we had something like tan n minus 2 of x, then tan squared of x dx. Where there is tan squared here, I had to replace with what? With the identity sec squared of x minus 1. But I won't do the same in this case for sec. I'll just integrate by pass just at this step, then we see what we're going to get. All right, so I will say, okay, I can set my u to be either sec to the power n minus 2x, or maybe sec squared of x. So I've decided to set my u to be sec n minus 2 of x, then my dv to be equals to sec squared of x. So I'm just trying to use one that will be much easier for me to work with in terms of either finding the integral or finding the derivative. So when you find the derivative of u, meaning the du dx, du will be equals to you're going to have your n minus 2, okay, n minus 2. Then the derivative of sec, okay, the derivative of sec is simply tan x sec x, like that. Okay, then you're going to reduce that power by 1, meaning to be sec n minus 3, then we have x there, like that. Okay, then our v will be equals to tan x. Okay, when you differentiate tan, you get sec squared. Okay, so we can try to simplify what we have here. Okay, meaning we have your du being equals to, of course this is dx there, sorry. So you have your n minus 2, then these two bases are the same, so you just have to add the powers, and you have a 1 here. Okay, so when you add, they are going to have tan x, then you're going to have sec n minus 2 x dx, like that. Okay, so multiplying of course by this formula, the integral of u dv is equals to uv minus integral of v du, which is the formula for integration by parts. You're going to find that the v by the u, we are going to have tan x multiplied by sec n minus 2 x, like that. Okay, minus the integral of v by du, and of course I have a coefficient here. I think I just have to bring it outside in advance, because we already have to put it outside. of your n minus 2, then the integral of you have your tan here, and you have another tan here. They're multiplying each other. You're going to have your what? Your tan squared of x, then you have your what? Your sec n minus 2 x there dx. Okay, so now this happens to be your tan x, then your sec n minus 2x minus, then n minus 2 integral of, we can set this to be sec squared of x minus 1, then we have your what? Your sec n minus 2 here x dx. So this one I just written it in terms of the identity, to say sec squared of x minus tan squared of x is equals to 1. So I just made tan squared of x the subject of the formula, and that's what I ended up with. Okay, so it's just a matter of taking it step by step, but of course we are not done. We still have a few more steps to go. Okay, so when you look at this part here, we just have to distribute the sec n minus 2 of x within the brackets that we have there. So we are going to have this will be equals to, we have our tan x, then sec n minus 2x minus n minus 2 here, then the integral of, we have your sec here, sec squared multiplied by that one. The bases are the same, so you add the powers. That will leave us with what? With sec n of x, then minus sec n minus 2 of x dx. Alright, so when you look at this part, this stage that we have reached, we have something here and we have that is similar, meaning we can write this in the form where we are going to have your tan x sec n minus 2 x minus, okay, your n minus 2, then the integral of sec n of x, then plus, there's a minus here and a minus here, so I multiply them, becomes a plus n minus 2. I'm just trying to write them as individual integrals, so we have n minus 2 here, x dx. So when you look at this part here, this is simply what we are looking for, but of course there's a coefficient of 1 here. So what I would want to do is that I'd want to write it in the form that I'm familiar with in terms of working with it. Okay, so since this part is what I'm looking for, I'm going to express it in terms of what? In terms of let's say I use the letter B. Okay, the letter B like that. So this part here is simply a B. Okay, so I'll say my B is equals to tan x sec n minus 2x minus this is a B, so that would be B here, n minus 2, then we have plus n minus 2 here, then we have your what? Your sec n minus 2 x dx. Okay, so just a matter of correcting the like terms. You're going to have your B here plus your B n minus 2 here being equals to your tan x sec n minus 2 x plus you have your n minus 2, then we have sec n minus 2 x dx. Right, so we can factor out the B. We have your B here, you have your 1 plus your n minus 2 is equals to your tan x sec n minus 2 x here plus n minus 2 integral of sec n minus 2 x dx. Alright, we are almost reaching the final stage, because here we just have to divide by because we are making B the subject of the formula, because B is what we are really looking for. So when you look at what we have here, this is simply B n minus 1. Okay, B n minus 1, of which we are going to say our B, and in this case our B is simply that part, and I'll just address it, or I'll just write it as the integral of sec nx dx being equals to, I'm going to divide both sides by what? By n minus 1. Okay, so meaning I'm going to have tan x sec n minus 2 x plus n minus 1, n minus 2 integral of sec n minus 2 x dx, of course divide by n minus 1 and n minus 1 there, and this happens to be the reduction formula for the one that involves sec, and that's how you go about it. Yeah, thank you very much for watching.